Some exponential equations require different ways to solve them. It could be that substitution is necessary to solve it, or that factoring out a GCF is the way to go. Here are two examples that show each option. So for the first equation, we have e to the 2x minus e to the x minus 6 equals 0. And we need to solve for x. We can't combine them. We can't just divide them out. We can't do anything like that. But what we can do is we can look at it and see that this is kind of in the form of a quadratic. This is what's called quadratic in form. So what I can do is a substitution by substituting out the middle term. So I can say, and you can use any letter you want, but typically the letter U is used, called a U substitution. U equals e to the x. Now we say that because we can go back to this equation and we can say, how many e to the x's do we have here? And the answer is we have 2. So we can say that it's u squared. And then how many e to the x's do we have in the middle? We can see that we have 1. So I could just say u. And how many e to the x's do we have for the last term? Nothing. So we just leave it as minus 6 equals 0. And this is much easier to solve. We can just factor it and figure out what the answer is. So, setting up my factored form, I know that what times what equals negative 6, but adds to give me negative 1 is negative 3 and positive 2. So I can say u equals, or u minus 3, and I can say u plus 2. And then I can solve each one of these for 0. So u minus 3 equals 0, u plus 2 equals 0, and solve. So I'm going to get u equals 3, and I'm going to get u equals negative 2. So I know what u equals for this. But we go back to the original equation. I don't have a u anywhere in here. I have x's. So what I've done is I've solved for u using the placeholder value, but now I still got to solve for x. The way to do that is we go back to our substitution, where u is equal to e to the x. So I can replace u with 3 and negative 2 respectively and solve for x, because that's much easier to do. So I could say that 3 equals e to the x and negative 2 equals e to the x. And so I'm going to solve each one of these individually. So to solve for x here, I'm going to take the natural log of both sides. So I'm going to get ln 3 equals ln e to the x. Move the x in front. So ln 3 equals x, and ln e just goes away. So I just have x. So x equals ln 3. Done for that one. Now I'm going to do the same steps here. Take the natural log of both sides. ln of negative 2 equals ln e to the x. And I can move the x in front. So ln of negative 2 equals x. And the ln e goes away. And now I have x equals ln 2. But if you remember, you can never take the natural log of 0 or a negative number. Well, ln negative 2 is not real. So we can just discard this because it's not a real answer. So the only answer we have for this equation is ln 3. Now we could try this one. 3x e to the x plus x squared e to the x equals 0. I can see that I have an e to the x common to both terms. Not only that, I can see that I have an x common to both terms, at least one. So I can actually factor out an x and an e to the x from everything. So I can say x e to the x, factor it out, and I'm left with a 3 plus a single x left over here equals 0. And now that I've done my GCF, I can set each individual part equal to 0. So x equals 0, e to the x equals 0, and 3 plus x equals 0. And now I can solve for all three of them. So for the first one, it's already done. X equals 0, done and over with. Very easy. Second one, got to take the natural log of both sides. So ln e to the x equals ln 0. And right here, I know I can stop. Because while this will simplify down to just x, over here I have ln 0. And like I said before, you cannot take the log or natural log of a negative number or 0. So I can just discard this. And the last one's really easy. I can just subtract 3 over, so x equals negative 3. So for this exponential equation, I have two possible answers, negative 3 and 0, with the third one here not being possible.